Our next entry is on solving quadratic equations by graphing. So quadratic equations in standard form are ax squared plus bx plus c. And I used color for this one, so my a was red, b was in blue, and c was in green. To solve this equation, we need a different strategy than what we've previously had before. Let me give you just a quick reminder of what we did in the beginning of the year. So please don't write this example down, but I just want to give you a refresher. Like I said, we want to solve this equation, for example, with variables on both sides. So I want to get x by itself. So my first step would be to subtract x from both sides. Right? That moves the x all the way over to the left side. And the result is 3x minus x is 2x plus 2 equals 4. And now I want to move everything away from the x to the other side. So I can subtract 2. I have 2x equals 2. Lastly, get x by itself. Divide by 2. X equals 1. So I've got x by itself equals some number. Right? And it makes sense because 3 times 1 is 3 plus 2 is 5. And that balances with 4 plus 1, which is 5. However, we're towards the end of Algebra 1 now. We're working with quadratic equations. What if I had a problem like this? X squared plus 2x equals 4. Now, what are some strategies I can do to solve that one? Well, I don't have any x's on the right side, so they're all on the same side, which is nice. However, right here I had 3x, I subtracted x. I can combine those two together to give me 2x. But this is x squared, and this is just 2x. So there's nothing I can do to combine those together. So I can't make that part any simpler. So now I have 2x's. So again, we're trying to look for a strategy. Well, one you might be thinking of is to take out the greatest common factor. So when I do that, I take out an x, and I'm left with x times the quantity x plus 2 equals 4. Which is a nice step because now I don't have any squares. Still, though, I have to get x by itself. What's something else I could do? Well, maybe divide by x plus 2. Divide by x plus 2. So that gets rid of that. So I'm left with x equals 4 over x plus 2. So I don't have any squares, and I have an x by itself, but now it's on two different sides. So we need some sort of strategy to solve a quadratic equation like this. And one of those strategies you're going to learn in this lesson is to solve it by graphing. So we're going to graph a quadratic equation and try and figure out what the solution is. My first example is to solve the equation x squared minus 1 equals 0. So what I want to do is I want to figure out at what values for x does this here equal 0. You might have it right in your head, but I want to start with a simpler example so you get used to solving in this method. So one thing we can do in one lesson, the lesson that this is on, is we're going to solve by graphing. So we're going to graph the equation y equals x squared minus 1. And we're going to figure out at what point do these values equal 0. So what point is y equal to 0? And let's graph this here. So just like when we graphed in the previous entry, we're going to choose some values for x. Our middle number, which is our axis of symmetry, is 0 because there's no middle term here. So I know that my numbers I can choose are -2, -1, 0, 1, and 2. And to find the corresponding y values, -2 squared, which is -2 times -2, is 4. Minus 1 gives me 3. Since it's symmetrical across here, I know that if -2 is 3, +2 is also 3. And then I evaluate for -1. -1 times -1 is +1. Minus 1 gives me 0. And then use symmetry. For this one, 0 squared is 0 minus 1 gives me negative 1. And now I'm ready to graph those solutions. So now that I have my coordinate plane, these are part of the resources for this lesson. We're going to plot these points. So at negative 2, the function is 3. At negative 1, the function is 0. At 0, it's negative 1. And then, of course, it's symmetrical, so this point here, and then that point there. And I can estimate that curve. It's going to kind of go up like that. And this whole curve here is x squared minus 1. And I'm looking for the values that make x squared minus 1 equal 0, because that's my solution for x. And those occur at the x-intercepts. And where are the x-intercepts in this one? Well, they're at negative 1 and positive 1. So the solution for this one, which are the x-intercepts, let's write it down here, x-intercepts are x equals negative 1 and positive 1. So those are my solutions. Now, this doesn't happen in every case, but I want to show you an easier example. If I just made my table, I could right away see that at negative 1 the solution is 0, and at positive 1 the solution is 0. So these are my solutions as well. So I didn't necessarily have to graph this one. Okay, but it's good practice to graph this one. I'm going to show you one other way to do it that's not graphically but algebraically. This one's going to be example 1, part B. Back to this page, you can see that we tried to solve x squared plus 2x equals 4 algebraically, but we weren't able to because we couldn't get the x by itself. Right? We had an x squared and a plus 2x, and I couldn't combine these two because this is x squared and this just means I have two x's. Now, in the example we were given here, our equation was simply x squared minus 1. So there is no value for b, okay, or b would be 0 in this case, so there's no middle term. In a case like this, I can actually get x by itself. So my steps in doing so would be to add 1 to both sides, leaving me with x squared equals positive 1. And my final step, remember I'm doing opposite operations to get x by itself. My final step would be to take the square root of both sides. And I'd come up with x equals, and what's the square root of 1? Well, 1 times 1 is 1. But be careful. If I solve this graphically or algebraically, or any other type of method that we use to solve quadratic equations and that you're about to learn, I should always have the same answer. So why do I have 2 here and 1 here? Well, let's think about square roots. 2 times 2 is 4, and that's why the square root of 4 is 2. But negative 2 times negative 2 is also 4. So isn't the square root of 4 both 2 and negative 2? Right? It is. So our solution when we take the square root is we have to account for the positive version and the negative version. So either way, we're going to get the same answer. And that kind of comes back to that symmetry that we were talking about. In general, when you're given an equation that has an exponent of 2, okay, if we take a look at the graph, if the exponent is 2, that means that it at some point is going to curve. And that means it's going to go normally across the line and then back up across the line, or the other way, over the line and then back down across the line. So it would occur twice, which means you would have 2 solutions. Now you may run into functions that are higher ordered. You don't have to write this down. But take a look at this one. This is x to the 4th. Every time you add an exponent to a polynomial and you try and graph it, it changes the curve. So if I just had y equals x, In this case, this line kind of looks more like y equals x plus 8. But notice that their only exponent there is 1, so it's a straight line. If I add a squared, then this becomes a curve. If I were to make it cubed, it would go back up. To the 4th, it would go back down. To the 6th, it would go, to the 5th, it would go back up. So every time it curves, it has another opportunity to cross that x-axis, which means generally, if you have an exponent of 4, you'll have 1, 2, 3, 4 solutions. Okay? Now that's not always the case, and don't write this one down, because what if you had an equation like this? Well, you can see in this one, the x-intercept occurs at 6. So it actually doesn't go below, it just touches it once. So this equation here would have one solution. But we're going to get into that later. So make sure if you did accidentally write that, make sure you erase it so you don't think it's part of the problem. On the left side, you're going to do this problem right here. You're going to solve x squared minus 9 equals 0 by graphing, part A, and then by taking the square root, part B. So you're going to solve it twice. So flip the page, and this is example 2. We're going to solve x squared plus 1 equals 0. Using the same method, we want to graph this using a table of values. So we're going to do x and y. And I want to graph the equation y equals x squared plus 1, because I'm trying to figure out at what point does y equal 0. When does x squared plus 1 equal 0? There's no middle number here, right? There's no bx, there's no 3x or 4x. So I know it's symmetrical across 0, so I can use my usual 5 values that I choose and just evaluate away. So at -2, the solution would be 5. And -1, it would be 2. At 0, it would be 1. And it's symmetrical, so I know that it's 2, and then back up to 5. And using that other coordinate plane that you would cut out, you're going to graph that one. So we've got -2 going up to 5. And we have -1 going to 2. 0 to 1, 1 to 2, and 2 to 5. And I estimate my curve, so it looks like that. So where does that cross the x-axis? At what value is that going to be 0? Well, it does not cross the x-axis, right? There's no way that this can be 0. X squared, whenever you square something, you always have a positive result. And so if you have a positive number and you add 1 to it, there's no way to make it lower than 1. There's no way it's going to be 0. So our solution is really no solution, because it does not cross the x-axis. It has no x-intercepts. So this one here would be no solution. Because it doesn't cross the x-axis. And we're also going to do this one algebraically. So we're going to do it by taking the square root. So scrolling down a little bit, we've got example 2b, solve x squared plus 1 equals 0. Using the same steps, I want to get x by itself. I can do this because I don't have a middle term. It's not x squared plus 2x plus 1 equals 0, right? So I have x squared by itself. If I subtract 1 from both sides, I'm left with x squared equals -1. And then I take the square root from both sides. And I'm left with x equals Well, what is the square root of negative 1? So you got to think about that for a second. We know 1 times 1 gives me 1, so that doesn't work. Negative 1 times positive 1 would give me negative 1. But when I square something, I'm multiplying it by itself, so I can't just change the sign. So whenever you have a square, we know that the result cannot be a negative number. So when you are multiplying a positive number times a positive number, it always equals a positive number. Like positive 2 times positive 2 is positive 4. So the square root of positive 4 is positive 2. Or it could be negative 2, because a negative times a negative is also a positive number. And since I can't change the sign when I multiply by the same number, my result is always positive. Which is why you can't take the square root of a negative number. So there's really no solution this way as well. Which matches my original statement that whether you solve this algebraically, graphically, or in the next lesson solving it by factoring, you're always going to get the same solution as long as you've done the math correctly. The very last step is to do this problem on the left side of your book. I included it on the first page, or the first left side, so it's underneath that example problem. You don't have to do that. You can put it on the left side of the next one if you want to match up. But you'll be solving x squared plus x squared plus 36 equals 0 by graphing and then by taking the square root. After that, you'll have the practice problems and you'll be ready to move on. Don't forget to have your teacher check your answers for both 1 and 2.